Hello. In this particular demonstration video, I'm going to compare the density representations of each of the objects that are provided on the screen. Now, in order to understand density, you must understand that it represents a ratio between mass of an object and its volume. And in this particular instance, we're comparing the mass using grams, and the volume is collected using milliliters. And we're looking at the displaced volume to ascertain or determine what our density is. And then we'll use that to compare them accordingly. So I'll start on the left and work my way to the right. I'm going to choose this object gold, and notice instantly as the gold is added, it caused the water to sink. Now, that metal as it's added causes the volume level of the water to rise. That is going to be our measured volume. We're going to need that. Equally, we're going to need our mass. Now, the mass of this object is 40.53. Now, if I'm trying to determine the density of this object, I'm going to take the mass of 40.53, and then I'm going to divide that by the displaced volume of this metal object. So, if it was originally 25.5 and it rises to 27.6, that's roughly a difference of about 2.1 milliliters. So to determine the density of gold, I'm going to take 40.53 grams and I'm going to divide that by 2.1 milliliters. And that will get me my density of gold. The next object I want to look at is the iron. I'm going to grab the iron. I'm going to grab the iron, and this object has a mass of 31.48. Its mass is less than that of the gold was. But we don't know how the density compares until we find the displaced volume. So let's look at the displaced volume. Before 25.5, and then as we add it, it sinks. And it rises significantly by 4 mils exactly. Look at that. 25.5 rises to 29.5. The displaced volume is 4 milliliters. To get the density of iron, you're simply going to take the value of 31.48 and you're going to divide that by 4. And that's going to give you the density of iron. Now, if we take another object here, and in this particular case, we take the lead, we're going to proceed with the same school of thought. The lead is 72.32. We're going to place that into our volume of water. That raises it up to 31.9. Now, the difference of that is even more than the previous one, which was the iron. In this case, you would subtract 31.9 from 25.5, thus giving you a value roughly of, I want to say, 6.4. So you're going to take 72.32 and divide by 6.4. The next object we'll look at briefly will be that of wood. Same school of thought. The wood is only 1.95 grams. I take the wood, and wood does something unique. It floats. It exhibits buoyancy. We're going to submerge it though, and that will give us the volume displaced by the wood block, and therefore 28.5 is our new volume. If the original volume was 25.5, that means it was 3 milliliters. So we're going to take 1.95, divide that by 3 milliliters. In the next object, we'll look at the rubber. The rubber object, or rubber block if you will, has a mass of 0.52 grams. Now, That 0.52 grams is going to be divided by the volume that's displaced. Let's go ahead and see if we can move this object. Notice it's buoyant, just like the other one was. And we're going to submerge it so that we can get the volume representation of the block. Originally 24.5. As I submerge it, it becomes a value of 25.9. So 0.52 divided by 0.4 will be what we use to determine the density of the rubber. Now next we're going to take the foam. The foam we're going to do the same thing. Take the mass, 2.76. Take 2.76 and we're going to submerge that into the volume of water. 25.5, when we add it, it becomes 37.5. Wow, that's a drastic increase in volume. If you subtract 37.5 from 25.5, you get a value of 12. So what we're going to do to find the density of the foam is you're going to take 2.76 and divide that by 12. Next, you have your ice. Ice is 9.2 grams. We're going to take the ice of 9.2 grams, submerge it in the water, and notice that the volume increases to 35.5. That means it's a volume of 10 milliliters. So to get the density of the ice, we're simply going to take 9.2 and divide that by 10 milliliters to get the density of that object. Now, once you determine the density value of the object, the more dense item is going to have a greater density value. That means its ratio of mass to volume is going to be much higher. Now, if it has a lower density value, then it is going to be of a lower density or least dense. So that's how that works in terms of determining density of objects.